Welcome to our Abundance of Water webinar. In the beginning, I'm going to answer most important questions about water self-sufficiency in the city environment. Then I'll take you on a full tour of our off-the-water grid city property, and we don't tap into borehole water. I don't believe that's allowed unless you're harvesting water using earthworks. And then at the end of the webinar, I'm going to give you a mind map of just the water section of the garden. I've got the rest of the mind map. If you're interested, I will be posting it at a later stage. But for now, I'll just give you a water section because as it is, it's an hour and 10-minute webinar. So I'm allowed you to scroll at the bottom so you can go to different sections if need be. Otherwise, I suggest you watch the whole thing because you are going to learn a ton of awesome stuff. Let's go for it. I'd like to just bring out a few key questions that some of our subscribers have been asking over and over again. So cutting pipes is no rocket science. As you can see behind me, we have cut and trimmed and pipes left, right and center. Here's the bath water that comes out here. That's now going to the wetland. Here's the shower, the sink. We have installed the toilet flushing device, so all the grey water is flushing our toilet. Cutting of pipes and joining them takes literally minutes. So it's just the most important thing is to get the levels correct so the water flows where you want it to. That's the most important thing to remember. The next question is, how do I take care of my needs without depleting the water table? Well, look, it's important to remember that for the water to absorb into the ground, it needs to be slowed down, and you need to have earthworks such as contourline berms, little speed bumps on contourline that allow the water to stop there and sink and infiltrate. So if you are doing the earthworks in the garden, then by all means you're more than welcome to put the borehole inside, because then you're replenishing the groundwater table and then you can suck some out. But until people do earthworks, they shouldn't be allowed to be putting boreholes because our water levels are dropping pretty rapidly underground. You see, without the earthworks, the water just skims over the top, and if the rain cannot get into the compacted soil at all. So without the earthworks, we would be running out of water completely at the rate we're going in about 20 years. So every single borehole will need to be gone deeper, and that's just totally not sustainable. Another interesting question is how to create a mobile abundance of water system that can be used in the rental property. Okay, so it's important to show you here that the biochar filter that I'm going to be showing you just now is the drums are 60 centimeters diameter, those 200-liter drums, and 4 of them fit exactly on a pallet. So you could, because the way that we do the biochar system, you can dismantle it and take out the gravel into the sandbags, because those sandbags are quite strong, and basically dismantle and take out all the ingredients and reassemble it at the new property. The same goes for the constructed wetlands, which we did in those flow bins, those 1,000-liter flow bins. They already come on a pallet with a cage and a waterproof drum, ridiculously cheap, like 400 Rand a drum. And that's also the same way. You remove all the plants gently, wrap them in newspaper, the roots so they stay wet, and then the ingredients again can go into thick, strong sandbags, and then you can relocate it with a small pickup or bakkie. You can move it to a rental property really, really easily. Another fantastic question from you guys is how to treat grey water without the smell or mosquitoes. It's a brilliant question. You see, in the grey water, in a constructed wetland, the roots do all the cleaning for you. So these lovely plants take out all the nitrogen and the nutrients which actually cause smell, and they suck it up for their own growth and fertilization. So the plants end up thriving whilst taking up all the smelly stuff out. And the way we construct our wetlands is you've got 3 layers there. You've got the gravel, which is the stone, and the gravel gets set up to the level of the water. Then there is sand, and then there is soil. and the sand acts as a barrier for soil to mix in with the gravel. And then when you got young plants, you plant them into the soil and a little bit into the gravel so they can reach the water immediately. And so what happens is the water is actually nowhere to be seen. The water is all in the gravel, and then there is sand and soil above that. And the soil acts as a biological filter, stopping all smells from going out, if there are any, which I haven't experienced in doing this for quite a few years. And the mosquitoes, of course, they can't get in or out because there is 20 centimeters of soil and sand above the water level. So that's how we do the grey water system safely, without any smell or algae or anything dodgy in your garden. Another quite important question is how to legalize a grey water system. Well, in America, where there is most lawsuits, where the municipalities are really strict, this is how the earthships have done it. They use a three-way valve, which you can see right now on the screen, and the three-way valve allows you to move your grey water through the wetland and out into your garden, or if you turn the lever, it takes that same grey water to the sewer. So should the municipalities ever do an inspection, in their mind this is just perfect, because it means that it's just a bypass. And should there ever be a problem with your grey water system that you made at home, then you can, they know that you can just turn the water to sewer, and for them, in their head, it is the same system. It just have a little diversion via grey water constructed wetlands. So that's the way they legalize it in America, and they've done it to thousands of homes with a three-way valve. Okay, here comes a really fun question. What is the return on investment in terms of a whole year with this water system? So here it's important to lump three components together. So let's talk for sake of exercise about a 12,000 liter ferrocement storage tank, and the reason it's 12,000 liters, it uses optimal materials to create it. So that takes about a weekend with 5 people, and the cost of that is no more than $300 or 5,000 rand, and that's 12,000 liters. Okay, then that water obviously will come off your roof. I'm assuming you've got some gutters, which they put in majority of the homes right now. Okay, so the water stored in the tank, you've got 12,000 liters. Then you've got the biochar filter, which on materials and the gravel and the biochar and everything you need and all the plumbing, we have constructed it in 2 days with 3 to 4 people, and the cost of that is about 3,000 rand or $200 with labor and everything else. Or if you're using your friends, obviously you can bring the price down. And then the last system is, of course, this grey water constructed wetland, which allows you to utilize the 12,000 liters that you've showered and been bathing with to reuse it again in the garden. So now with that system, which takes a day for 3 people or even 2 people, and also about 2,000 rand or $150 only, so now you've got 24,000 liters that you'd usually draw from municipality. Now you've got that available. So, and that ferrocement tank, depends on the size of the roof, can fill up after one good rain. So you could use that water twice a month. So let's say that that water tank during rainy season will allow you to be completely disconnected off the grid, of the municipal water grid, and you have 24,000 liters for half the year. Okay, so the cost return on investment depends on the price of your water. I've calculated that you can pay off the entire system in less than a year, and then for the rest of your life, for the next 100 years, you have free water. And obviously, to be completely off the water grid, you just need to build more storage. And as I said, those are $300 a pop, and you've got 12,000 liters, and then you can link them up and off you go. So for me, that's pretty exceptional return on investment. If any of these answers are unclear or there's something you're unsure of, please post your comments into the comment section underneath this webinar, and we will attend to it in the best way possible. The reverse osmosis filter is also not the answer, because it strips the water of all the vital minerals, the good and the bad, leaving the water quite hungry. So when you drink this water, it takes in the minerals from your body and binds them to itself, and then you urinate them out, and that's how all these minerals leave your body. The long-term effects, well, you don't have to go far. Just go and ask my mom, who after just 6 months of using the reverse osmosis filter started to get violent and painful muscle cramps because her body was so malnourished of the minerals. And just to remind you, the reverse osmosis filter uses 4 liters of water to flush itself for every 1 liter of pure water produced. But that water is dead. And for the rest of us who have no choice but to use the tap water for bathing and drinking, with maybe a small water filter at home, majority of these chemicals are still entering our bodies, and they accumulate in our kidneys, in our livers, completely taking out the joy levels, increasing the frequency of the diseases, flu, and of course our intuition goes out of the window because we're just so polluted by all this junk. In fact, we're being slowly poisoned from outside in through our skin and inside out through our digestive system. But it's not all doom and gloom. This biochar system behind me, we made ourselves with 3 people in 1 weekend, and including the biochar, which we got we got wattle for that and burnt our own biochar in the gasifier oven. The whole procedure was a weekend, and it cost us no more than 2,000 Rand or $150. And it delivers 300 liters of pristine spring water into the house at 300 liters per day. If you were to cost a standard system out that will give you 300 liters per day, you'll be shocked to hear that it's roughly 50,000 Rand or at least $4,000, and the quality of water is practically the same. Alright, so let's go on a journey through our secret self-sustainable garden, and where I'm going to show you some of these simple systems that we have made. Lovely lemongrass and mint and beautiful herbs growing here, but what I want to show you is the sewage pipe that we've shown you, that's going towards a biogas digester, sloping at 3 degrees all the way down from around the corner all the way, and the biogas digester is just there. You can't really see it because it's underneath the ground, and that biogas digester in just a couple of weeks will be providing us with methane gas, mainly for cooking, to top up for cooking, and we'll plumb it back into our gas geyser, so we'll have backup gas if that other gas runs out, using our methane from poo, from our toilet water. Here you can see behind me some of the multiple earthworks that we've done. We've massively terraced our entire garden. So before it was all slopey, and we've just made it into terraces that are taking all the rainwater that comes down from the sky and just soaks it up like a sponge. There is no soil erosion, and we're basically recharging the groundwater. And these beds with mulch, compost and then mulch, retain the water for weeks after the last rain. So you use up to 12 to 15 times less irrigation or less rain that you need to keep this bed nice and juicy. So here's our awesome pool. And that's the filtration that I wanted to show you. A solar pump lying in the pool, 1 panel, and the water is just silently circulating, and it's dropping through back into the pool, and this is amazing living water. This is what we should be striving for. As I said earlier, having 120,000 liter backup of water that you can drink is just phenomenal. I mean, I don't even need a filter to drink this water. I know my plants. I know my plants. They're doing all the great work. This is clear. Phenomenal. This water is amazing. So even in the tiniest of spaces, a balcony or patio, you could grow a variety of microgreens and leafy greens that will provide you with all the nutritional value that you actually need. I mean, like this food grower is growing 120 vegetables on 1.2 square meters, as well as 10 trays of wheatgrass, seedlings, and microgreens. Just 5 minutes a day, that's all I'm spending on this. And it's growing an abundance of vegetables. I mean, look at this creeping spinach. It's gone up my window, which could be your balcony, and totally edible. The tomato plant that flew out of there, it's got fantastic little tomatoes. It's just abundance of food on such a small space. Just to remind you that sprouts and microgreens have up to 10,000 times more nutritional value per weight than the full-grown plant. That's because the seed shoots all the nutrients into the little seedling, and it's just full of really awesome goodness. And the best part of all, it is irrigated by treated grey water that you just had a bath and shower with yesterday, and all of this abundance is just pumping through. And it has this food has my DNA because of my skin particles that rub off whilst I shower and bath, and that skin carries my DNA. So all these vegetables are impregnated with my DNA, and they have my information about the body. So if I ever get sick, they know about that even before I do. And by growing them out, I'm able to get the nutrients from the cosmic forces and the earthly forces of everything I need to stay healed and healthy. Imagine your brain firing up after eating this nutritionally dense, freshly picked organic produce, and then you're increasing your intuition so you could listen to your inner voice with such clarity, almost the same way as your close friend speaking right in your ear. That is the power of freshly grown organic produce that's picked right there and then, juiced and produced into nutrition for your body. What would it feel like to be so clear within yourself after eating this nutritionally dense food that you can partner up with our Creator, manifesting your dreams and possibly avoiding those misfortunate circumstances that keep on happening to us every time we are off our path or not following our divine purpose on earth? What if you could turn your karma into labor of love, connecting with living things out there in the garden or in your balcony, and inspiring others to do the same? Just gardening a little bit here and there brings such joy to me, and I just want to share it with everybody else. So here's some lovely new additions. We've got a rocket stove that uses a handful of sticks to make a meal, a solar oven that can bake at about 150 degrees Celsius. I'm getting a vacuum tube that goes up to 300 degrees Celsius, which I don't have as yet. And here's solar dish that you can boil water, cook a meal for free for the rest of your life. And just to show you the power of the sun, watch this. If this is not a proof enough, I don't know what else will work. So here is a sandbag water tank that we've constructed, 16,000 liters. The cost of materials were 1,000 rand, maybe 2,000 rand with waterproofing, and 16,000 liters, and that's going to be feeding our biochar filter, and what's feeding the tanks is all our gutters, and from both roofs. The thatch roof, we've created the gutters, and the tin roof. So that's feeding the tank. Let me show you. So right behind me is the 16,000 liter water tank. As you can see, the leaf catchers are important parts of any storage because they keep the muck away. We were probably one of the first crazy people in the world that put the gutters onto the thatch, and what I had to do is make socks for the gutters using shade cloth, which trap all the debris that's coming off the grass as it degrades away. And this is the latest addition. It's called the First Flush from our tin roof, because we don't have a leaf catcher there. So all the bird poo and pollution and dirt runs into the tank, this tank. When this tank fills up, then the excess water fall into our main tank, so we get much cleaner water. And this valve behind me will extend the pipe and run it to irrigate the compost pile. And the reason for that thick valve is so we can blast the water out with all the leaves and muck and bird poo one time. So with the total water storage of 200,000 liters in this tiny property in the middle of the city, without tapping into ancient aquifers, you would agree with me that I have taken self-sustainability with my passion to a whole new level. So here's a lovely component, got an avocado tree coming out, but a lovely component is a earthworm bath. You can use a real upcycled bath, or in our case we're using a piece of a 1,000-liter drum. So it's got a pipe that comes down here, and basically earthworm tea just drips out into this bucket daily, and then we can put it to our plants. So that's liquid gold. We feed them kitchen waste, no citrus, no onion, no meat, no fish, no fat. So banana peels, tea bags, everything else. Uncooked generally, and all the peels go here, and we've got millions of worms, millions, and they are eating this with your green grass clippings and they turn it into soil in 2 weeks. So feed them green grass or brown leaves and your kitchen waste, and they wee out liquid gold. And let me show you the worms. Oh, you're gonna love this. Don't get a fright. This is what's doing the job. Look at that. That's my bath is just full of that. And they eat twice their weight in, I think, a day. Twice their weight in a day. That's just awesome. That's biology doing the cleaning of the smelly stuff that you smell behind the garbage trucks. No smell. Could probably eat this. So this is the pump that delivers 3-bar pressure from the biochar filter into the house on demand. As we open the tap, the pump kicks in, and we've got pressurized spring drinking water in all of our taps in the house. So here's our biodiesel plant that will be producing diesel for our vehicles from restaurant fried oil, upcycled oil. That's really awesome. And then the washout will flush into a biogas digester to produce methane gas, again closing the loops. And here's our lovely solar system with the battery bank behind me that provides for all of our electrical needs, keeping us completely off grid. So we're actually operating autonomously from the government system. So here's a ferrocement tank, an awesome contraption. Can build it for 5,000 Rand, and it takes 12,000 liters of water. So that's more than 2.5 times cheaper than actually getting a plastic water tank. And a weekend with a couple of friends, like 5 people, can get this thing done. So here we've got our first biochar system that we constructed. It was on a pallet originally, now we've separated it a bit. And basically this ferrocement tank behind me that will feed these drums, and the drums provide us clean drinking water to the house. It gives us 300 liters per day. And here's a tap of really phenomenal drinking water. So plenty abundance. So here is another massive pavement. I mean, it's about 200 square meters, which can get a lot of water. So what we have done is I've created, that's the lowest point there with those 4 pipes, and I'm going to show you where they go, because that's really was one of the crucial systems here. And whilst I'm here, just to show you, these are the terraces that we have created to sponge up whatever rain comes from the sky. Alright, so here we've got 4 pipes, and let me explain to you where they go. Alright, so here's just another angle. Just have a look there. That's the 4 pipes that I was just talking about. So the one pipe comes in here underneath this concrete and goes to flush out the trench. So that's that. It comes out just there underneath the step, and the trench runs along these stepping stones. I know the garden is messy, but we just haven't got to it with my leg. But basically the trench runs underneath there, and the trench is filled with sticks and yeah, just lots of sticks. So all these stepping stones are actually quite spongy when you walk on them, and that allows the kitchen water from the grease trap that you learned last week to enter the trench really fast. There is a fat pipe, 40 mil pipe that's running. Here it is. Okay, so that's feeding from the grease trap, that black pipe. Okay, and then in the trench it's got 50 mil, or no, actually 1 centimeter holes cut into it every half a meter at 5 o'clock and 7 o'clock. The reason that we cut those holes at 5 and 7 o'clock is so the dirt does not get in, and they basically release the water every half meter along this whole trench. And the trench is level, absolutely level, and it's on contour line, and the soil from the trench on this side will make a bump, which you don't see here because it's all overgrown with pumpkins, and that bump is basically what is, you plant all your herbs, flowers, and that bump will be forever wet, because as the pipe releases water into the trench, and the trench is filled with sticks, so sticks allow the water just to exit. Then we have another pipe here which basically allows the water to exit out of there, and it all falls into this gravel, and the gravel, as you know, allows water to travel through. So the water, copious amounts of water, travels through this gravel, and I've made branches that go left, right, and basically feeds into the vegetable garden. I'll show you just now. Okay, the third pipe goes to the aquaponics system, which is still messy. We haven't finished it. We're probably going to remove this liner and do a nice plastering job. And there is the pipe, just to show you. Here it is. So that's the 4th pipe, and then it will feed aquaponics system. But as I said, we haven't touched it yet, but you know, I've made provisions for it. And then the 4th pipe, which enters here, you can see a bit of detail. Okay, so that's the 4th pipe. I've reduced it to and that basically drops in here, and will feed this wetland that overflows into that wetland, which overflows into those 2 wetlands. So I've perfected the system so well that within 2 minutes after I release the bath and shower water, it irrigates our entire garden automatically with these sprinklers, and it's treated grey water, no smell at all, and I'm getting completely wet. That is the power of self-regenerative design. This is the power of what you can do with permaculture and applying your God's given brain. So this is just our latest wetland made out of bricks. So hence it hasn't been yet established, but an established wetland eventually looks beautiful like that. So we're just still working on this, work in progress. Quite experimental. But yeah, let me show you what happens with this gravel. Oh, sorry, whilst I'm here, important, this is a really cool tool. You can get it on eBay. I haven't found it in South Africa. It's called a siphoning pump for automotive industry to drain carburetors. So my bath downstairs is way too low, so I cannot enter the wetland because all the plumbing is hidden, and you're going to have some of your downstairs toilets and bathrooms and showers, the plumbing is just hidden. So what I do is you put a pipe here, and this thing could live just outside the window. You suck it up, and it's basically like a siphoning that you know, the experiment, and then you pull it down. So this is what this pipe does. It does that movement and basically sucks up the water from the bath. Then you have the other pipe lower at your wetland and basically drains the bath right out for 100 Rand, yeah, all the bath water just gets drained. That's no plumbing, no cutting of pipes. This is fantastic piece of equipment, and it will allow you to start experimenting with saving 200 liters every time you bath, and even you could drain it to a nearby tree. So this is our latest addition. We've just plumbed this up, so when the pump from the grey water wetland was treated bath and shower water switches on to irrigate the garden, it also pumps water right, filling that entire system up. And then the idea is to have the filter doing additional treatment so the water can come out in the toilet really clean. Not that you want it super clean, but it's going to look 7-star and clear. There is the gas geyser, which is awesome system that's to get off the grid in terms of electricity. So what we did here that's so different is we created a special temperature valve that allowed that kicks in the gas geyser when the solar geyser drops below 55 degrees. And because this is a biological system outside, as you can see, we had a bit of hail, some hail damage, but still thriving, phenomenal. There's a sugar cane behind me. Look at these papyruses, and this is 1/2 meter deeper than me, so the ground level is here for them. So here is another system, same system. So this gravel that gets that massive amount of runaway water from the pavement, the water will enter here and disperse into the garden. I've got these branches, I've got 3 of these branches created down the garden, and basically it will feed the garden passively with water every time it rains, and the excess will go into the garden, into the aquifer. Oh, look at this butternut. Oh gosh, there's produce everywhere. I hope it doesn't, yeah, look at that. Fantastic. So, you know, although it looks messy, there's food. There's great food and a lovely butternut I'm going to enjoy tonight for soup. And here I'm walking on top of a 50-meter long wall that weighed over 300 tons that we made with our hands using earth and sandbags. And we've interweaved pockets where additional 20,000 liters of water can be stored inside our wall in these segments, which are going all the way down. That is a really awesome project. We just completed at the end of last year. In the following video, I will be showing you an entire mind map that will show you how all the other systems all work together, such as chicken tractor, which is crucial in the garden, compost piles that can generate water, food forest, as well as bio-intense vegetable garden, and all the waste and how it can all link up together, creating an entire web of an ecosystem in your garden that you do not have to spend much time managing this, because systems are self-maintaining. For example, if you have a little chicken coop and that you make the upflow from your veggie garden, every time the chickens scratch, that stuff is easily and will be moved towards your garden, fertilizing your garden with chicken manure. All right, so grease trap. Okay, so you can find this in any plastic shop. So what we did here is you go to the plastic shop and you experiment. So you see here, like this basket just fits nicely here. How's that? Look at that. So the basket, you'll need a piece of mesh, which I don't have here with me, but I'll show you in the grease trap, the other one. It can be a shade cloth mesh that you just line here and you put 4 pieces of gut. If you take gut and you cut it at an angle, like a sharp or a needle with thread, or you take a fisherman's gut and you cut it at an angle, you can pierce it through, tie it through, and you've got a shade cloth net or whatever net you've got, but it's a much finer net, but allows water but stops the pieces. And this obviously stops the big pieces. And here we've got a tank connector. So a tank connector, and there's a variety of ones. You know, the washer, the rubber washer must be going on the inside. So this will sit like this, obviously at the bottom, then it will go through, and then the rubber washer must be on the inside, not the outside. If you got two, great. You can have one on the inside, on the outside, but the main one that you need is the rubber washer on the inside. So this particular tank connector has got 40 mil thread on one side, which you can connect this piece. You get a thread to 2-inch standard PVC pipe. Here it is. This is a normal PVC pipe. It fits in nicely here, and then it's got the 40 mil thread. I don't know what's it in America, but it's the standard thread that one fits into the next. So you don't want to reduce it too much, because you know, when you release a lot of kitchen water, you want it to just come out. If you make this, because it's coming out of this pipe, this thickness pipe, so you don't want to go too small in the ends. That's why we've gone for 50 mil outlet, which again, you can get these in elbow or straight. So this is an elbow, and that 50 mil outlet will fit on the outside. So basically we'll sit at the bottom of the box and will allow the cleaned kitchen water to travel via a fat 50 mil pipe anywhere you want. I'll show you the pipe just now. It's a black polyprop pipe. Okay, then what we're going to be doing here is, from the pipe outside the kitchen, there is you know, outlet that's coming out. We're going to plug in that outlet off from there, and we're going to divert it with a T, or with this piece, in fact. Okay, so it was straight down to the drain. We're going to cut that straight piece out, and we're going to insert this piece. Don't worry if you're in a rental property, because you can put a stopper at the end and cup it so it still does the same thing as it was doing before, but you just have this option. So then you can have the length, any length of pipe that you need, and then you have a valve. Okay, so what this valve does, and that's why if you get us checked out by the owner, I'm sure they won't mind you installing something like this, even in a rental property. So typical kitchen outlet, this piece of pipe could be any length, and then this valve allows the water to either go straight to the sewer, the main sewer line, which is basically takes that water away out of your house, such as if you're washing something with highly toxic chemicals, or your children just had a nice painting session and you've got a whole bunch of paints and you don't want those paints going in your garden onto your tree. You open this valve, this is the open position, and all that water goes through out into the drain. Or if you close this valve, okay, now this water is going to back up and is going to go through a grease trap. So it makes sense so far. So this is going to come in here. Then we're going to insert another 45-degree elbow, which I'll show you just now. That's going to go into here, and that elbow is going to come in and is going to go through this, and the water will allow to go into the basket. So that's the inlet pretty much. The inlet, we're not going to use a tank connector because our water level is going to be about here. So there's no need to use expensive tank connector such as this to go through there. You can just have the straight PVC pipe entering into the top part here. You can have a bit of silicone around it, or not even, because as I said, the water is not going to back out there. The water level is going to be, you control the water level where you put the outlets. Okay, then what else you'll need is you'll need to create a little cut plate from plastic, or yeah, plastic would be the best if you could find a little piece of plastic like that, and that guy basically fits in here. Okay, so what he's going to do is you're going to have the kitchen water coming in one end here on top. He's going to drop into the basket with your mesh. Okay, and then that water is going to fall down, and then you're going to glue this with silicone on the sides. And the bottom, you're going to leave maybe 3-4 millimeter gap. So what's going to happen is all the fats from your frying pans and oils, they float on top. So this little plastic plate is going to keep the fats here. So once every 2-3 weeks, you could clean out those fats with a sieve and chuck them into your compost pile, or you know, if you don't have such, you just throw that away into your toilet or whatever. Okay, we'll be throwing it into our biogas digester because those fats are actually very good at producing methane gas, which is, you know, gas that can be used for heating or cooking. Okay, so now you've got fats here and you've got bits and pieces that are here. So you've got much cleaner water that you're going to install this T-piece right here at the bottom. Okay, so in fact the height where you position this T-piece is going to control the water level. So you don't want it too low, because you must remember that water flows downwards only. So one of the main rules we have in catching of water is squander no fall, which means don't squander any fall if you don't have to. So we're going to try and make it as high as possible. So with this piece being slightly higher than the plate, which this plastic plate, which means that it will not suck in any fats into it. Okay, the reason that we're using a T-piece here, so the water basically will come in from the bottom through and out, for main reason that siphoning effect, that it's better that it takes some air with it so the water can really flush out real fast. So as you're draining your 2 sinks at the same time, I'd prefer to drain 1 sink at the same time, but anyway, it can drain out real quick and go out. Okay, so here I'm going to use a mark. I'm just going to mark where I want it outside by comparing and, you know, feeling and tapping. But basically, or you can use a measuring tape and you measure the height. And the T-piece will be connected by a short piece of PVC, which you can cut with a metal saw or hacksaw. Will be connected short like this to each other. Okay, and then that will go through. So our tank connector will fit onto that, and then the other piece of the tank connector will sit here and making this watertight. This is important to be watertight because you don't want that water to be constantly dripping out here. So that's where we're going to use a proper tank connector. And then of course on the outside we're going to use our 50 mil elbow, but most of the time it's probably straight. But if you want to bring it close to the wall and then run it, you'll need another elbow, and then you'll push it straight along the wall towards your fruit tree or trench in the garden. And then of course you're going to use your drill, and you've got your 50 mil connector, which is the same diameter as just slightly bigger than the pipe, and the pipe will fit nicely. So that's your test, and then that's how you're going to make holes in there. Here's the 50 mil pipe. It doesn't have to be so big. It's quite big, as you can see. I used 40, but you know, we had a 50 mil tank connector, so now we're going to be using a 50 mil pipe. So the way to dress these pipes is using a gas torch and I'm going to be showing you now how that is done. Otherwise it's quite tight, you know, it's actually literally impossible to fit it in. Okay, the gas torch, so just like this, you up, down, you're warming it up, and you can hit it on the inside or you can go underneath here. Just makes the pipe a bit soft. Don't breathe the smoke in. Smoke is not good to breathe. And I'd say that's sufficient. Let's try it out. Look at that. Just comes in. Perfect. That's what I wanted to show you. So that's how you're going to insert all the pipes in. Okay, so let's do a rough assembly. So we want the water to come in obviously just above here. Okay. And I've got a handle here, so I probably need to, I'll probably drill through the other side. We don't need this handle here because I need to go as high as I can here. We'll see if we can insert the handle back after we drill, but the drilling part, getting this as high as possible is important, or higher than the basket. So, you know, that I'm quite comfortable to drill here. Best to get pressure. Yeah, that's it. That's how easy it is. Oh, but we need to get through this handle part. All right, so that's about it. That's you know, really no rocket science here in drilling these pieces. So that's where we're going to have our straight piece coming in. You could add a bit of silicone here from an inside or outside for a snugger fit. All right, so that's our inlet. So now let's check out what we're going to do for outlets here. So we test everything out where we're going to have that. Okay, so just above the plate. I want to have it as high as possible, but not lower than this plate. So I think at least let's go for 2 centimeters higher than the plate. See if that's going to go in. Okay, so this is a bit too big. So we're going to take a sharp knife and we're just going to shave it out a bit. And by the way, if you don't have the drill with that attachment, you can just slice in, and you can, once you got a nice mark, you know, you put a pipe on, you mark it with a permanent mark or whatever, pen, you cut it out with a knife. It's also possible. Okay, just something I noticed, that it's easier to cut at a bit of an angle, because obviously a knife being straight and wide, it doesn't allow you to cut that easily. So this angle cutting did quite well. You've got forgiveness. The piece is so wide. So remember what I said, the washer needs to be on the inside. Here, and you see now you don't see your dodgy cutting. The washer must go on the inside as well, because that's going to create a rubber seal. Yeah, you just do it hand tight, okay? And then you could use the plumber's wrench, obviously, that's also a super important tool. You screw in your 50mm adapter. I want to bring it as close as possible. To measure the pipe, if you want to cut a short piece just to join, you know, it goes in about 2 centimeters, so you roughly 4 centimeters. And then you use this hacksaw. Alright, so this goes into the T-piece, and that goes on the inside. So that's the construct of the inside, nice and easy. And then we're obviously going to have our plastic plate here. Yeah, this is our construct on the outside with another 45-degree elbow, a short piece, and obviously you can make it as long as you need to. Then a 45-degree elbow, and because there is no high pressure here, you don't even need to glue these pieces at all. Okay. Yeah, and then you obviously put your piece in here as long as you need it. And that's it. That's it. So that will, so your old pipe that goes down into the drain obviously gets cut. This gets positioned in there. Okay. The outlet of your fat pipe that I showed you, which we fitted in, obviously goes in here. You can use a bit of plumber's tape, but really there's also no pressure here. Nothing is going to leak here. But you know, just for good safety, if you want a bit of plumber's tape, which is that cheap white tape, you get it, you just put it around the thread, a couple of rounds, and then off you go. So as you can see that this inlet is higher, so the water level will be the bottom of the outlet always. So that's going to be your water level. And remember, the plastic plate is there just to separate the fats. So you could push it a bit higher, just so it's above the water level. At the bottom of the plastic plate is the gap. You can glue this up with a bit of silicone. Just the tube, bath silicone, you squirt here, sides, but leave the bottom open so the water can travel underneath, and then the plastic plate will keep the fats one side. And just to give you a heads up, so that's the shade cloth. So this is a very important part of the grease trap. Although the basket is great, but it's not going to catch the bits and pieces. And why would I want bits and pieces? Because eventually it will be a pile of nasties rotting next to your tree. And you don't want that. Or if you're running it through a pipe, which will feed a trench through lots of little holes, then on level, then you also will block up those holes. So this now obviously will be set up. You can use a bit of gut, as I explained. You cut it at a sharp angle, thick gut, semi-thick, like 16 kilogram breaking strength. Cut it at an angle, and then you just put 4 corners here, and you can stitch it around the edge on top, just roughly. Doesn't have to be anything fancy, doesn't have to be anything pretty. The main idea is that you have this basket, and then you can trim up the excess. So you've got the basket with a shade cloth, second layer in front, and then once a week on somebody's checklist is going to be to take this basket out and you just blast it out with a hose pipe over your compost pile or down into the drain. Another thing I have to explain to you is that in your kitchen sink where you've got the outlets, do get yourself those super low cost additional screens that you can fit in there. the less you throw down the sink, the less cleaning out you have to do out of those little screens on the outlets of the kitchen sink, and then the less that this guy gets filled up. That's it, that's the grease trap. So now this outlet water to your fruit tree, and what I'd suggest to do around the fruit tree is make a little volcano, so it's nice and wide. Depends on the size of the tree, but make a little volcano that's got raised edges. Then this pipe can go in there, cover it with mulch, okay, and then which is grass clippings, brown grass clippings, nice spread around, and then this will feed the tree underneath the mulch. At the end of that fat pipe you could put a T-split, and you can have two smaller pipes going out to reduce it to 2 or even 4 pipes. As long as they're on level, then you could have multiple trees being fed through this grease trap. Alright, so here we are on portable water. So although everything else is very, very important, having water is crucial. We cannot survive without water for more than 3 days, and neither can our plants. So water is the foundation of the entire self-sustainable living. So this is the focus for this year, for me, and for the last 9 years, is this getting water to the house and recycling the water. So here we go. Let me explain to you in detail. So we obviously need to make sure that we have delivery of water to our house, which happens by 2 ways. Either you have a big tower, which is quite ugly in the city, but that'll give you 10-meter tower can give you 1 bar pressure, so which is not a lot of pressure. Generally what comes out of your taps is about 2 to 3 bar. So having a 30-meter tower is just not acceptable. So the other way to do it is having a small pressure pump, as you've seen in the previous video, and that'll just, as soon as you open a tap, the pump kicks in and gives you pressurized water to your house. And that water is, you can disconnect, have a special valve, basically disconnecting your municipality grid with a valve, turn it around, and then turn another valve to allow this pump water to be plumbed into the house. Well, it's already all plumbed, but to the water, so the water can go into the house. Revitalization, I hope I spelled it correct, but that's super important, because although water can be cleaned, it's not living water. And a simple revitalization instrument is a vortex pipe, which I'll be showing in the future how to make in our training actually. And or flow forms. Flow forms are a really fun and beautiful way to revitalize water. So if you want to just Google flow forms, they're done by John Wilkins from 1970s. Fantastic way to vortex and get water to be living water. And what is living water is what Dr. Emoto photographed as those beautiful crystal particles, by blessing the water, saying thank you to water. So you can do all of that, but if you want to automate things, you just put a vortex pipe on your copper inlet pipe into the house, and then all the water coming in will be living water. So to feed the revitalization part or the delivery to the house, you need a filter that will filter your water at a fast rate, so you can have enough water to bath, shower and drink. And you want all this water to be super clean, because our skin, being the biggest organ, absorbs everything that comes out of a tap or that you get submersed in. So filtration is important, and as I've shown you in the previous video, that biochar filter, I had the water tested by Setpoint, which is one of the local companies, and the water came about 20 to 100 times better than tap water coming out of the tap. Really phenomenal quality, and it was a low-cost DIY filter. And of course then we have storage that feeds the filtration, and here we have a variety of options. I have a ferrocement tank. Beauty about that, you can build it for 2.5 times to 3 times cheaper than a plastic tank. It will last you 50 to 100 years
longer than a plastic one, and keeping your water cool. And it's obviously a lot more beautiful than having a plastic tank, and you can give it a bit of shape. You can even make it look like a beautiful huge pot in the garden. It all depends on your craftsmanship skills, but a simple is just a cylinder tank looking like Jojo, but it will be made out of ferrocement. I have a sandbag tank that I was sitting next to. The cost of materials was about 2,000 Rand or $150. Phenomenally cheap. Labor was about a week and a half for 4 guys, but fantastic. 16,000 liters. I molded it to a straight wall and just adding a beautiful honeycomb effect to an area. So it fits in nicely to any straight wall. You can sculpt it according to your pathway. That's the beauty about sandbags, that you're not limited by straight lines at all. So if there's a tree in a way, you go around the tree, and they're very easy to make. Plastic tank, that's conventional. In our course, we actually do cover retrofitting of the plastic tanks to make it basically to create a flush out valve. So all the gunk that sits at the bottom of the plastic tank, the only way to get it out currently is to go in there on hands and knees and basically scoop out the last 200-300 liters with a bucket, and then mop it up with a sponge to the last drop so you can clean out all the stuff. Because as soon as the leaves get to the point, or the muck gets to a point of your outlet, which is about 10-15 centimeters higher than the floor, then basically all those leaves and mucks and bird poo are going to start going into your filtration system, and you don't want that. So in the sandbag tank that we've constructed and a ferrocement tank, we made a valve right at the lowest part of the floor, and we actually slanted the floor, and it blasts it out completely. So you have this fat valve that you can blast the water out with all the muck, and then your outlet that feeds the filter is about 15 centimeters higher than that, so your filter is always getting much cleaner water. The beauty, if you've built a successful storage, if the water coming out of the tank is cleaner due to settling than the water that's coming in from your roof. So all this dirt settles at the bottom and you can blast it out, and as I said, the outlet is slightly higher, getting much cleaner water in. You've succeeded that way. So we do go through how to retrofit a plastic tank. It's quite easy. Underground tank, the beauty about this, okay, so it's all got benefits and drawbacks. The benefits is that you put a tank in massive, 40,000 liters, 50,000 liters, and you build a dome above it, or if it's a rectangular tank, you build a vault, which is a singular curvature roof. There's lots of traditional vaults out there, you can Google, but anyway, so it's a ferrocement vault, and then so it's a rounded roof, but it's in the top of the roof is in the same level as the ground. So then you add the soil to completely cover it. So when you walk on top of it, it looks like the rest of your garden. And then you obviously got the manhole, which gives you access to in and out of the tank, maintain your pump or clean out if you ever need. And then the manhole obviously must have a ladder on such a big tank. In fact, anything taller than you should have even just a rope that just hangs in there, because if your kids, somebody just plays and then they fall in, at least with this ladder, they will be able to get out. So crucial to have just a rope ladder, something to be able to come out of the tank. Because obviously this is now 3 meters deep, about 4 meters wide, and either rectangular shape, as I said, or round shape, which I'm constructing in my garden. And the drawback of this is that you want super clean water going in here. So you want like maybe a preliminary filter, like a gravel and sand filter, just a simple filter that will take care of any muck that's coming in. You want a leaf catcher first, and then maybe even a first flush. So you want basically super clean water going in, because the only way to get the muck out of this thing is to pump the water out, the remainder of it, and of course then you go and you broom it up and you sweep it and you take the rest out. And then of course we've got eco pool, and in a lot of properties already have eco pools. Well, I mean normal pools, and then a conversion to an eco pool is quite simple. It's very similar to the constructed wetlands that I've been showing you. It was gravel, and you don't see the water at all. Well, I've got two types of wetland. The one you do see the water, and that's where you plant your water lilies, which are very, very beautiful. And then whenever I find any frogs, I just throw them in there. And then I've got the main filter, which doesn't use. You don't see the water. I mean, the water is in the ground level, and then above it is gravel, and then you plant all your plants into the gravel, and voila, you've got a natural pool, and the plants do all the treatment for you. They take out the nutrients, and the nutrients is what make your pool go green and funny. So the plants use up nutrients and algae to thrive, and algae cannot really grow in, I wouldn't say sterile, but the water got no nutrient value in it. So the algae doesn't really like that. So that's how you control your algae levels. You just put in more plants, and the plants take care of algae because it can't thrive in a sterile water. But it's not sterile, it's actually living water. There's a lot of life that's happening. There's little bugs on the floor of the pool. And then I still have my barracuda running for about an hour and a half a day, which does the cleaning of the scrubbing of the floor and picking up of the algae, the little bit of algae that I have. It does settle at the bottom, and the barracuda picks it up. Or once a week we'll have a gardener that just can vacuum it up for half an hour. Anything that settles, if you don't want to run barracuda at all the whole week, that's also perfect. And then the rest of the time my solar panel takes over and does its thing, and just circulates through both wetlands, and then the water drops back into the pool, and that's how it works. And then we have eco pond. Very simple construction here. You don't even need, you could add a little pump that just circulates the water in itself and has a little water feature. It could be nice for sound, definitely having some waterfall sound in your garden. But the beauty about the pond is that you literally put the plants around the edge of the pond, which you can do that in a pool if it's like a whole serious retrofit and you big building skills, But the pond, it's much easier. You actually have the plants submersed in the pond in little special baskets, also have a bit of gravel, and then the roots are in the gravel, and then the frogs come, and you can have a couple of fish there. Really awesome with kids. Your kids are going to love it. You're going to love it. There's going to be dragonflies and just lots of life. It's just awesome. All right, so what feeds the storage is your harvesting. So you need to harvest water to get it into storage. And so there's hard surface. So anything hard, meaning it's not soft ground, grass or whatever. Anything hard is a pavement, road or roof. So we'll start with a roof, and the roof needs a leaf catcher. A leaf catcher is something that basically catches the leaves that are sitting in your gutter or lying on top of your roof, and the leaf catcher doesn't allow those leaves to go into your storage. It's a nice leaf catcher will let the water in, but the leaves, it will blast it out when the gushes of water coming in from the rain, the torrents are coming in, and then the leaves will fall to one side, and the cleaner water will go inside, and it's got a fine screen. And then, of course, the gutters get fed from there, from your roof. And look, the quality of the roof is also important. I've got the worst roof for catching water, and that's a grass roof. And the problem with grass roof, it just leaches a whole bunch of constantly, obviously rotting grass. Not a problem, it's not toxic or anything, but definitely the pollution gets stuck to that grass, and then so that's why it's super important for me to have a leaf catcher. And what I've done is I made socks for all my gutters that are out of shade netting, like socks, like your pants you wear. So they're put right across all the gutters, and they make sure that those particles, majority of those particles get stuck on top of the shade cloth, getting the cleaner water in. Because if I have to take those socks off, my gutters would be full after 2 weeks, literally full of just dead grass. So at least this way they stay on top, and then when the sun comes out, they dry up, and a bit of wind or it just blows them off the sock. And then I have obviously somebody that, more in my case, a gardener that comes once a month, and then he just uses a little broom and he just cleans out the gutters or anything that's sitting on top there from those socks. So maintenance is important. Another interesting way is to have a ground trench around your roof. It's quite an easy way, especially for grass roofs. This would be very interesting to do and definitely will work. But you have a trench, let's say 20 centimeters or 30 centimeters wide, right underneath where the water falls. So obviously in a harsh rain, you need to go out and see where the water falls. Maybe, draw it out or make notes or scratch it on your bricks or wherever you want to make this. And then you dig out a trench, similar to French drain, let's say 30 by 30 by 30 centimeters, or not even that deep, maybe even 20 centimeters deep, which is the size of your spade, the end of your spade, the shovel part of your spade. So let's imagine that trench, and then that runs right around your house. Make sure you get your slope correct, obviously. So, shave the soil so to the point where you want this water to flow towards the central point. And then you fill that trench. I would put same as French drain, bitumen cloth all the way around, and then just sides, bottom, and I would actually. And then I'd put the stones, the gravel, right into that trench, and then I'd cover the bitumen cloth, the top of the stones as well. So what this will make sure that these stones will never get mud in them, and the bitumen cloth allows the water to penetrate quite easily. And what I would do is I'll put a layer of gravel on top, so you don't see this cloth at all. So you just see gravel, and what happens is any water coming down from your roof will drop into this trench because it's so porous, gravel being such big pore spaces between it, and bitumen allows water to come in, but yet the muck out, and then you have basically cleaner water going into your water. So the drawback with that is that you can't harvest water at height, because you want to try and get water as high as possible so it can feed your biochar filter, or you can feed your filter without a pump. As soon as you have this trench, you basically keeping the water right in the ground level, and your storage will need to be obviously lower than that. That means that any water that you want to get into the house must be pumped up. Well, it will have to be pumped anyway with pressure to pressurize into the house, but now you have to have an extra pump to have the water being pumped into your filter. So, so this would be great, for example, to top up your pool. But again, I wouldn't run it into the pool straight away because my pool went super green when I channeled my rainwater from my roof into my pool. So I'd put that first into the wetland and then let the wetland overflow into the pool. But these are these are little logistics of that. Another interesting thing, as you saw last week, when you saw that movie, in the previous movie, the webinar series, I installed the first flash. And the first flash is basically a drum, and it replaces a leaf catcher. So it allows all the water from your gutters and your roof to first fill up that drum. So if it hasn't rained for a month, let's say, and your roof is a bit dirty, so all the water coming in, the first 200 liters or the size of this drum will be obviously filled up with dirty water and leaves and whatever is muck there. You don't want too many leaves either, so you do want to maintain your gutters, once in a while, just have them cleaned out, especially in autumn, after autumn when there's a big leaf fall. But let's say your gutter's got like a few leaves and bird poo and a bit of pollution and some dirt stuck to the roof. So the first flush will take all that water, and when that drum gets filled up, all the extra water goes into your storage. So leaving the storage with much cleaner water, and then the first flush, you've got also a big valve and you blast that water out into your garden or wherever, and all the leaves and bird poo actually go there and not into your storage. So that's quite important. And then if you can also catch water from pavement and road, but you'll need to have a preliminary debris trap, whether it's a screen of some sort, because with the road can come a lot of sediment, and paving obviously less, but especially road definitely have some preliminary trap for sediment trap. I don't go into it now for the sake of time, but just it would look something like even a little trench or hole in the ground where it allows the debris to fall in and be screened by a finer mesh, and then the cleaner water goes through and then overflows into your garden and wherever you want to send it to. But this is a lot of water. We're talking you could have 400,000 liters come down, and if you're not watching it in one rain, especially on the road. So the road runoff is something I would do as a last thing once you've experienced with everything else, but it's masses of water. You could you could fill up your entire pool 3 times in one rain. And then you've got paving. Paving is a much cleaner water because it's your paving. It's just, your car standing, providing it's not leaking oil. And paving that I've shown you in the previous video, that where I've got the water going into my garden with 4 big 10 centimeter pipes, and then that water is going into the garden, into my aquaculture system, to flush out the wetlands. So you can channel it in different directions. Watch the previous video, just the system I created.